Hidden in the heart of a primitive forest in southwest China, there lies a metal colossus. This gigantic structure is FAST, the most powerful and sensitive radio telescope in the world. A monster with a diameter of 500 meters and weighing 10,000 tons, it was designed and built by the government of China. This megastructure searches for distant signals that will reveal the secrets of the cosmos. Secrets that will help map the Milky Way, but also discover the force on which the expansion of the universe depends. And perhaps even capture the signs of an extraterrestrial civilization.
The first word that comes to my mind is mind-blowing.
The figures are dizzying. 10 years to build, thousands of workers.
那种场地条件很苛刻，那作业面很窄小。
Its steel frame weighs 5,600 tons, equivalent to 40 blue whales. Its reflector measures 150,000 square meters. It listens to radio waves coming from the farthest reaches of space. A receiver with 19 multi-frequency antennae captures the signals of the cosmos in unprecedented definition.
只是尺度那么大的是第一次。 就是世界上是第一次。
For 10 years, we've followed the construction of this pharaonic project, and for the first time, we're going to reveal its secrets. This is FAST, a gigantic radio telescope. Its aim is to expand our knowledge of the universe. It listens to radio waves coming from the farthest reaches of the cosmos. Waves that optical telescopes cannot pick up. It operates 24 hours a day, 7 days a week. And with FAST, everything is enormous. It's a 10,000-ton metal monster. These 6 towers are gigantic. They're almost 170 meters high. The circumference of its steel frame measures over 1.5 kilometers. Its reflector is composed of an incredible mosaic of 4,450 pieces. Its diameter measures 500 meters. Its reception cabin, equipped with ultra-modern digital tools, is a masterpiece of innovation.
那肯定是现在来讲是世界上灵敏度最高的望远镜，所以说，很多人对它是抱有很大的希望。
The fabulous adventure of FAST began in 1993. Astronomers from all over the world meet in Kyoto. They had to admit a serious problem. In just a few decades, scientists would no longer be able to observe the sky from Earth. A disastrous outcome caused by man. The technological boom of the last 30 years has created terrible electromagnetic pollution invisible to the naked eye. These parasitic waves disturb the efficiency of radio telescopes.
射电望远镜生存面临的问题，这个电波环境毁坏之前，这个再看一眼这个原初宇宙。
Following this alarming observation, China proposed to build a single reflector radio telescope. It would be the largest in the world, a radio telescope of 500 meters in diameter, enabling us to listen to the waves of the universe with unprecedented precision and range.
The Chinese are going to make the observing time available to scientists from around the world, which is fine.
The go-ahead was given in the summer of 1994. And the first step was a serious challenge. The Chinese engineers and scientists had to find a rare gem, an ideal site for the radio telescope. A real challenge because the specifications were extremely demanding.
If we were to build a big single dish like that, it's in a natural depression in the ground. It's the only way to support something of that size.
The Chinese engineers then searched for a natural quarry at least 600 meters wide. They were equipped with a topographic survey tool, able to detect the slightest detail of the ground's composition. And to find the perfect location, the engineers assessed over 1,000 sites across China. After more than 10 years of a quest that could sometimes be compared to that of the Holy Grail, they finally find an exceptional and unique quarry in Daodang in southwest China.
这正是就是到大窝当就是我就在印象中就是出这一个仙境一样，就世外桃源，就是一个是高兴觉得这个地方很原始。
The first advantage? This basin, 800 meters in diameter, is completely isolated. The nearest city is 70 kilometers away. This remoteness meets the #1 requirement for FAST, to be protected from radio waves produced by civilization.
首先，它肯定无线电干扰是没有了。那我第一个就感觉就是，周围都没什么人嘛，对不对？它的一个山头把它围得好很圆的一个。
The second requirement was the ground had to be able to support the considerable weight of FAST. This megastructure would weigh 10,000 tons. That's the weight of the Eiffel Tower. Another advantage, the Daodang Basin is made up of extremely resistant limestone rock, which perfectly meets the specifications.
第二个，我的岩石是坚硬的，是吧？每平方米可以承好几百吨，是吧？这完全达到你的强度的要求了。
The quarry has one last advantage. It drains rainwater perfectly. As thousands of tons of metal and highly sensitive IT systems will be installed there, a flood would be simply catastrophic. The site of Daodang meets all the geological criteria to host a giant radio telescope. In May 2008, Chinese engineers and scientists decide to build FAST in the Daodang quarry. After 14 years of studies, research, and exploration, construction can finally begin. December 2008, in the Daodang quarry, a gigantic open-air construction site begins. Thousands of workers housed on site are recruited to build a metal colossus.
所以我再三强调的还是安全问题，在同志们共同掌握了生产的技能，安全把子的关。
The building site teams have a multitude of stages to complete in order to build the largest radio telescope in the world. A daunting challenge, but one which they must overcome.
那么那个时候，我们说这个坑，还是郁郁葱葱的一个长满了树的一个坑。那么。 也想象不出来工程建设会有多么的难。
The slopes are steep, access is restricted, and the weather is capricious. Yet the electronics and mechanics of FAST can't withstand the slightest flooding. So the teams dig a water excavation tunnel through the mountain. FAST must be stable, solidly anchored to the ground. workers dig 200 shafts, each over 10 meters deep. They want to make sure the ground is strong enough to support the radio telescope. They also build roads to transport the raw materials.
工地不停工，你让我们员工还有在那儿干活的，所有的企业在那儿干活。
A construction site in a race against time, disturbed by the region's climate, a mixture of acid rain and extreme humidity. If the workers want to succeed in respecting the schedule imposed by the engineers, they will literally have to move mountains. Repeatedly using dynamite, they create a kind of bed to accommodate fast. March 2013. The site is ready. Construction can begin. The workers must assemble in the quarry a steel ring with a circumference of 1,570 meters. This will be the framework for the radio telescope. The first stage of the assembly, fixing 50 pillars to the ground. These will support the metal ring. This ring weighs 1,600 tons. To build this ring, the teams assembled thousands of beams by welding them together, one by one. Each piece of the frame weighs several dozen tons. This enormous weight pushes the engineers to completely rethink their scaffolding and lifting systems.
我们采用的滑移呢是这样子的啊，有一个滑移的托架，我们呢把圈梁在某一个特定的位置，那么再从那个滑移胎架呢，慢慢的。
An ingenious system that means workers can connect one block per day. But one more constraint has been added. This time, the constraint is linked to the laws of physics. The ring is made of steel, so it expands with variations in temperature.
白天施工到晚上，那个变化是相当大的。我们这样做在中间测量过，超出30公分，30厘米，有这么大的一个变形量。
The engineers scheduled their work by choosing the time of day when the temperature deforms the metal the least. The optimum time is 3:30 a.m. And after 6 months of hard work, the frame's ring will finally be connected. The evening of December 31st, 2013, the last block of metal approaches its final position. The operation is complex because the margin of error is less than 1 centimeter. It's 11:30 p.m. The block fits perfectly in its place. The positioning difference, so feared by the engineers, is less than 9 millimeters, over a distance of 1,570 meters, so precision is close to 100%. January 2014. FAST has its skeleton. To capture signals coming from far away, It now needs the largest reflecting surface ever built for a telescope. A wave reflector of 500 meters in diameter, it will be installed on a metal mesh assembled by these workers. Workers are perched in suspended platforms over 50 meters above the ground. The panels of the reflecting surface of FAST will be fixed to it later. To avoid the difficulty of transporting these panels, workers assemble them on site in this open-air factory. This giant net rests on hydraulic cylinders. These cylinders will help to accurately angle the reflecting surface towards the farthest reaches of the universe. In total, 2,000 cylinders are necessary. These parts are also assembled on site inside this immense factory. These cylinders will have to support several tons of pressure, and for decades to come. To guarantee perfect quality and reliability, each part is made entirely by hand. Once the mesh is installed, a metal mosaic is attached to it. It is made of perforated aluminum panels.
那么这种空间结构呢？那么由100个小的三角形组合成一个大的11米的三角形，这么一种结构。那么这样呢，就在我们后面的设计，我们就把它固化成这种结构了。
The structure will be more solid, consolidated by these panels. But their installation is the most perilous step yet of the FAST project. The 4,450 pieces of the giant puzzle weigh nearly half a ton each. They're suspended by a cable 30 meters above the void. The slightest drop would cause serious damage to the entire structure. On top of that, each piece must slot in precisely. The slightest deviation in positioning could have repercussions on the entire reflecting surface.
那么我们这个系统里头呢，由于它这个反射面面积的巨大呀，我们在这个施工过程中呢，工期上是对我们压力是非常大的。
Despite this pressure, the last panel of the FAST reflector is installed after a year's work. To celebrate the end of the first stage of the project, a balloon release is organized. It symbolizes China's gaze up at the sky. The next step is more technical and just as delicate. To capture the radio waves coming from the depths of the universe, FAST needs an extremely sensitive receiver. The teams must build 6 towers to hold it. Each tower is 170 meters high. At the top of each tower, a gigantic pulley, which supports a steel cable 46 millimeters in diameter. The engineers will suspend the centerpiece of FAST to the end of these cables. This feed cabin weighs 30 tons and is 13 meters wide. It weighs the same as a semi-trailer and at its heart holds technological treasures. It is equipped with 19 antennae, which will pick up radio waves. Each beam can be configured to detect different frequencies. This means scientists will be able to observe frequencies ranging from 1 millihertz to 7 gigahertz. By collecting the results of each beam's observations, the scientists will be able to observe immense and remote zones of space with unprecedented definition. Another advantage is that the 19 antennae are installed on a 6-armed robotic platform.
大家熟知的一个机构，像我们平时生活中最常见的就是飞行模拟器。
This mechanism means that they can aim at targets with impressive precision, located millions, even billions of light years away. Such extreme distances force the engineers to create a subtle blend of cutting-edge precision technology and intelligent mechanics.
因为它有很多的困难，就是很多的，觉得可能不太好实现的地方，所以它有挑战性在里面。
They must supply the feed cabin with electricity, protect it from lightning, enable it to transfer data, and of course, be able to position it accurately. In November 2015, a prototype of the cabin is finally ready. A first lifting test can be programmed. On the big day, tension is at its peak for the engineers.
而且在开始做测试的时候，要好多人分区分批的看着，说：“哎，开始张拉了。”大家对讲机啊，或者是通信系统都用上，赶紧停。那时候非常紧张。
The cabin gradually rises into the air. It has to reach an altitude of 140 meters above the void. A major challenge remains to be accomplished. Fast engineers will have to design and manufacture a special cable. It is fixed to the steel rope that supports the feed cabin. This cable will initially supply the cabin with electricity. But above all, it must ensure the transfer of an infinite amount of collected data.
对我这里，我还有一项关键技术没有攻克，而且它是卡脖子的。如果你没有这根光缆，就是说你望远镜收集了再多的信号，收集到馈源舱了，但它传不出来。
The cabin produces a very large amount of data. It needs 22 gigabytes per minute to store its observations. This is equivalent to the storage capacity of a Blu-ray disc. To transfer such astronomical amounts of data, they'll need to use fiber optic cables. But there's a major problem. Conventional optical cables may offer impressive transfer rates, but they're extremely fragile.
工程师们，花了不是4年就攻克了吗？攻克了之后，你不是就有了个世界第一的光缆吗？你相当于把这一项指标提高了100倍，提高了2个数量级，就是从我们最后研制出的光缆是可以弯折10万次的。
This cable is called a curtain cable because it can be folded 100,000 times, like an accordion. This technology is extremely flexible but also very strong, and the throughput it offers is exceptional. This cable is used to transfer collected data to storage servers. To avoid any loss of signal due to the distance, these servers were installed at less than 500 meters from the radio telescope. September 25th, 2016. It's the big day. In the presence of the Chinese Vice Premier, the fast radio telescope is to be officially launched. For the teams, the tension rises. But 10 minutes before the launch, a technical problem threatens to keep the feed cabin on the ground. A problem with the laser beam could block the whole inauguration.
让苍井奥平台让是谁负责？
那个
金立斌吧？
不是金立斌，就是小的那个小。
你回去说一下吧。苍井奥平台那总是配不上的话，这个锁和舱太危险了。
行。
In the feed cabin, the engineers have only a few seconds to fix the problem.
陈队，可以开始升舱了吗？要准备升舱。
你俩聊聊天。
Seconds tick by, but finally.
陈队，已经到了目标位置了，升舱已经结束了，人员都可以撤了。
It is 3:30 p.m. The problem is finally solved. The cabin can rise. After 8 years of hard work, the construction of FAST is finished. This radio telescope will enable a gigantic leap forward in our knowledge of the universe. Autumn 2016. After years of work, FAST, the titan of stellar observation, is ready to probe the universe. It starts to search for distant signals. In space, stars, planets, and even stellar dust emit electromagnetic waves. They can be observed by several means.
可能那个老百姓比较熟悉的就是，我觉得还是跟医学那个比较像，就是说那个 X 光、超声波，然后当然简单的肉眼看，其实就用可见光看。我们那个天文也一样。
The best known tool to observe these electromagnetic waves is the optical telescope, a telescope that captures light waves. The VLT in Chile, the Hubble Space Telescope, and SALT in South Africa. All these telescopes provide precise observations today, but they have their limits. Temperature variations in the atmosphere or even solar winds deflect the light waves these telescopes want to observe.
但有很多那个星系里面，比如它有星际介质，我们要有尘埃，像那黑暗夜里面云你是看不见的，肉眼看不见的东西，但它存在的。那怎么去发现它呢？那我们就用我们这种射电的手段。
To observe what is invisible, FAST will focus on radio waves, waves undetectable by optical telescopes. FAST is therefore built and programmed to detect radio waves. These waves are the resonance of cosmic elements far, far away. The incoming radio waves rain down onto the radio telescope's huge reflector dish before bouncing off toward the overhead feed cabin 140 meters up. Thanks to its onboard computer equipment, this receiver will convert the signals into digital data. It will then transfer them to the computer center. The storage servers located there will then send the results to the scientists in the form of images and graphics. It has taken FAST engineers over 25 years of research to make this process work. In order to perceive the invisible, they have developed technology on a cosmic scale. Technology that holds revolutionary innovations. When a telescope observes the depths of the cosmos, its main constraint is to aim perfectly at its target. To sharpen FAST's aiming precision to the maximum, engineers have developed an incredibly ingenious system. The mosaic that makes up the FAST reflector is attached to a metal net. A net that is soft and flexible, and therefore adjustable. This means the reflecting surface can be completely deformed. The orientation of its 4,450 panels can be adjusted with extreme precision. This mobility is ensured by 2,225 winches. And each winch can be activated separately.
So very, very sophisticated system. The computer control of all of this is impressive.
With a simple command, the winches can move the huge reflector panels. The waves coming from space will be oriented to be sent accurately to the feed cabin. With such precision targeting, FAST can continuously track the same celestial body.
I think it is a game changer, yes. It will be a fantastic survey telescope. You know, the Chinese have taken this to a new level.
This unique technique of deforming the reflecting surface is revolutionary. But this is not the only innovation developed by FAST engineers. To observe the unknown, they had to go even farther. The engineers developed an automated system that enables the feed cabin to orient itself perfectly.
对于这么大一个尺度的这种柔性的一个并联机器人来说，是特别困难的一件事情。对我们来说，也是一个前所未有，就是没有任何惯例的这种挑战。
With a 13-meter wide cabin weighing 30 tons, they had to think of robustness and longevity. Everything starts with the 6 towers. At the foot of the towers, extremely powerful motors pull the steel cable to which the feed cabin is attached. These cables must be able to support the cabin's weight for decades to come.
如果其中的一根钢丝绳发生断裂的时候，那么对望远镜来说，这一条长就相当于从高空当中甩下一根70吨的力量的这种长鞭子，那么对望远镜肯定是一个灾难性的影响、破坏。
And this risk is real. For example, December 2020. After 60 years of loyal service, the Arecibo radio telescope was totally destroyed after one of the platform support cables snapped. To avoid such a catastrophe, FAST engineers opted for a 46-millimeter braided steel cable, which is theoretically unbreakable. So the engineers adjust the length of these cables very slowly and carefully, using traction motors. In this way, they can position the cabin wherever they want with optimal precision. The margin of error is less than half a centimeter for cables measuring over 1 kilometer. Supporting a 13-ton cabin, all of this at 140 meters above the void. In order to orient the cabin perfectly so as to be able to precisely capture the waves coming from the universe, the structure of FAST is mobile and can be deformed. But these are not the only capacities developed by the engineers. You have to go inside the feed cabin to discover the fruits of their labor. The receiving tools are installed on a robotic platform. It's called the Stewart platform after its English inventor.
Six ways of moving, and this enables the position to be kept to, I think it's about 1 millimeter or so.
To summarize, FAST can deform its reflector. It can position its feed cabin perfectly. And it can adjust its 19 antennae with millimetric precision. It is this triple adjustment system which means that today, FAST is the most precise radio telescope in the world. If the innovations of FAST are amazing, a final challenge must be met. FAST must be able to operate 24/7, so its engineers must compensate for the Earth's rotation. By rotating on itself, our planet poses a real handicap to any telescope fixed to the ground. Its target is not immobile. The most concrete example that helps us understand this problem is when we observe the moon during a whole night. Not easy with a star that seems to move. FAST also suffers from these constraints, so the team creates an automated system that can take into account the slightest square inch of the radio telescope.
There needs to be all sorts of clever ways of controlling that, controlling the system in the focal cabin, and so that's an innovation.
These applications allow the engineers to continuously modify its structure. For example, FAST can compensate for stellar motion and therefore track targets for hours on end. March 2017. In Darodang's quarry, a race against time is underway. All the elements of FAST are in place, but now they have to be made operational. The future of the radio telescope is at stake during the debugging phase.
它就有一系列的这个困难，对吧？它的重量它也上去了，那么你的对你的控制的相对精度的要求也就更加提高。
To be able to deform a reflector weighing several thousand tons and to move a cabin suspended 140 meters from the ground in order to observe areas located billions of light years away, FAST must be 100% operational. This radio telescope has the capacity to carry out several types of research at the same time. The program is impressive. On the agenda, pulsars, neutral hydrogen, and dark energy. Everything starts with a mission worthy of the best science fiction novels. FAST is going to make a map that will allow us to precisely find our bearings in the immensity of our galaxy. Since the beginning of time, man has been an explorer. And man's next adventure could well take place in the Milky Way. But to navigate through the cosmos, the explorer of tomorrow will need some reference points. Without them, man will run the risk of getting lost in the middle of nothingness, isolated light years away from any assistance.
如果以后我们真的某一天我们都跳出太阳系的范畴，你要去在宇宙中航行的时候，你可能就收不到地球的信号了。你只能通过在宇宙中找宇宙中的坐标那个定标。
That is why since 2017, FAST scientists have been mapping the Milky Way. Their landmarks? Pulsars. Those stellar objects coming from giant stars almost 10 times bigger than our Sun. And just like our Sun, they're not eternal. Reaching the end of their life, they collapse in on themselves as supernovas. And from that, all that will last is a neutron star, a sphere of about 10 kilometers in diameter with insane physical properties. Some of these stars can rotate at a rate of 1,000 revolutions per second.
This allows beams of radio radiation to be formed. It's like a lighthouse, and since it's rapidly rotating, as the beam comes into the line of sight of the Earth, we can pick up the radio signal.
Their extreme rotation propels pulsing radio waves through the universe, hence their name, pulsars. It is thanks to these stellar beacons that future travelers of the cosmos will be able to find their way back. Analyzing them will also help us to better understand the behavior of gravitational waves and discover black holes. Therefore, the hunt for pulsars has become a priority for the FAST teams. But mapping our galaxy is not the only challenge that FAST engineers have set themselves. October 2019. The telescope is so powerful that it can perform several searches at the same time. One of the many promises is to try to understand how our universe developed. To do this, researchers will observe the simplest and the most present element in the cosmos, natural hydrogen. It accumulates in immense clouds of gas, which represent more than half of the visible matter that makes up the universe.
因为宇宙中间的物质呢，主要就是原子氢气，它的总质量远远超过你肉眼可见的所有的这个太阳、所有的星系的总和。
It is in these clouds of natural hydrogen that stars are born. By observing these clouds, FAST should give us a better understanding of phenomena that enable the universe to develop, a universe that, until today, has revealed only 20% of its secrets. Secrets that scientists hope to discover with this new tool. After mapping our galaxy, astronomers at FAST are taking on a new challenge. They're going to try to identify a form of energy capable of pushing back the boundaries of the universe, an energy that no telescope in the world has ever been able to prove exists, an invisible energy known as dark energy, which has the scientific world in a panic. Is it a still unknown matter? An anti-gravitational force? The hypotheses are numerous, a mystery that the researchers at FAST intend to shed light on. To achieve this, they'll have to analyze the movements of the giants of the universe, the clouds of basic gas, like the clusters of galaxies which extend over millions of light years.
你知道它在那儿，怎么去找？那你就是通过那个有一种东西去能够，空气也许是透明的，你什么也看不到。
This draft-like movement is what we call vacuum energy or dark energy.
但你喷一团烟，这烟在空气里飘，你就看得到哦，原来这个烟一看见烟在飘，你就知道有风在吹，或者有东西在动。
With its giant reflector, FAST hopes to discover the nature of the force that has the power to push the boundaries of the universe. March 2020, FAST is finally 100% operational. Now debugged, it can assemble the different axes of research. Astronomers want to understand the universe by studying neutral hydrogen and dark energy. But these scientific challenges are not the only ones. Researchers want to discover more than the laws of the cosmos. They also want to listen to what is hidden in it. For example, possible forms of extraterrestrial life. They commence the search for radio signals coming from the universe.
是在我们地球上自己产生演化出来的呢，还是外边就有生命的前期物质？
So, by pointing fast to the far reaches of space, researchers may well discover the unthinkable.
在这种条件合适的情况下，不应该光我们地球上面有智能生命，是不是？
The universe has about 2,000 billion galaxies. Our galaxy contains about 300 billion stars and 100 billion planets. With such numbers, civilizations should have appeared in places other than on Earth. With its hypersensitive sensor, FAST is today the indispensable tool that might help humanity intercept messages emitted by extraterrestrial civilizations. FAST researchers want to go farther and develop their radio telescope's capabilities to the maximum. FAST is specialized in observing huge areas, but it must also be able to detect details.
It does so as a wide field camera, so to speak. So it can't see the detail in these objects.
That is why FAST teams collaborate with international partners. Allies who have telescopes that are specifically designed to look for details. For example, when FAST detects a potential pulsar, it needs the help of the Australian telescope to confirm its discovery. A shared ambition is to eventually set up a network of several telescopes to create a super telescope.
Create a telescope as large as the separation between the furthest separation of the telescopes. So you can make a telescope as large as the Earth, in fact even larger than that, because there are telescopes been on satellites going in orbit around the planet.
The development of such a network would allow man to probe the universe even more deeply, and FAST is now part of that. By building FAST, China now has its place among the major countries looking at the sky. This machine is impressive on all levels. Its reflector of 500 meters in diameter is the largest in the world. The mechanics set up to compensate for the Earth's rotation is unique. Positioning is accurate down to the slightest millimeter. Its feed cabin, armed with 19 antennae, enables it to listen to the confines of the universe. This tool was created thanks to engineers, builders, and scientists. 14 years of research, almost 10 years of construction, thousands of tons of rubble, trucks, cranes, explosions. That made it possible to create this new worldwide reference in the observation of the universe. A tool that will give us a giant leap forward in the understanding of our origins. A tool that wants to prove we are not alone in the universe.